this is Russ Andersson. In the second part of our tutorial, we're going to take a look at the initial linear mode tracking of our 360 VR scene. So we're going to start by opening up the shot. And one key point here is that we want to mark that it is in fact a 360 VR shot. You'll notice there's also a remove option that'll be used automatically by some of the scripts later. And it can also be set manually, of course, too. But we've just opened it up, and I'll point out this is a nice shot by the 360 Heroes people that make some nice little rigs for GoPro cameras. So we're just going to give them a little shout out bug on the screen here. They were very kind to provide this. So here's our shot, and like any 360 type shot, the part in the center of the image here amounts to looking straight ahead from the camera. The part off to each edge is looking behind, and you've got the North Pole across the top and the South Pole across the bottom. So what we're going to do to be able to process this using SynthEyes is to convert it to a linear, normal kind of camera, just as if we were a viewing application, a Google Cardboard sort of application or whatever that picks out a view for presentation on some goggles or whatever. So there's a script to be able to do that. You'll notice there's a whole little area of 360 VR scripts available now. So the one we're going to run is this setup, and there are a couple key numbers here that control what direction the camera is looking within the scene. If we had the camera looking straight ahead, it would be looking right at the ultralight, and consequently you wouldn't be tracking the surrounding countryside at all. And so that's a bad idea. So instead we want to be looking off to the side, out of the way of that, so that we see the background. And we also get the chance at this time to set up what field of view we want for the linearized camera. And that number is going to be used directly during the 3D solve as a known field of view. So it's not something that SynthEyes has to recalculate again later, because we've already know it, we've generated it directly. You'll see we also get to pick the resolution and aspect ratio of the footage. So let's hit go on that, and now you start to see this view appears just like it would in a head-mounted display or whatever. And now SynthEyes is running through and generating that view into the RAM cache. So we can scrub through it. And while it's doing that, let's go over to the features panel. And I'm just going to adjust some of the auto tracker parameters to ensure that we get enough trackers in the area that we want, which actually is on the screen right now. That's going to be right here, which is pretty much the only flat piece of ground in this shot. So with that set up, we're ready to go and fire up the auto tracker. And it's going through and looking for trackable features. And then it goes and does the 3D solve to determine where everything is. And you'll notice that 80-degree field of view is being used here exactly within that solve. So once that's been done, we've got tracker locations. There's actually a camera path up there that we'll look at in a moment. And it's already set up a little bit of an initial coordinate system, just kind of using an average ground plane. But we actually want to go and do our own ground plane more explicitly with a couple of trackers in this little flat portion of ground. So we'll go over to the coordinates panel and hit *3. And now we're just going to wipe out that existing one. And we'll use that tracker as the origin. This other one over here on the x-axis. And this third one is somewhere on the ground plane. So with that, it just goes and updates the solve. And now we have our scene. So it's oriented, correctly in the vertical direction. Normally we would like to use trackers that are much further apart within this image to be able to generate the ground plane. But in this particular case, we're working with the side of a mountain, and that seems to be pretty much the flat part that's around. So we had to roll with that. So now we have our solve, and at this point, like with any auto track, we can go and take a look at trackers that aren't as good, and you'll see actually that quite a few of the trackers have relatively high errors. That's because of the whole stitching process that's involved in the VR process and the fact that maybe the cameras aren't all synchronized. So we do see typically higher errors. So you just run up higher and you'll notice we get down to 4 or 5 trackers that seem to be substantially worse than the rest of them. So we'll just take those out and then re-update the solve here. So that improves it a bit and gets rid of some of those lesser quality trackers. So let's take a look now at the camera path. Here are our trackers. Here's our camera path. Scrub through the shot. There's our camera looking off to the side. This is a tracker that's been labeled a far tracker. Let's just get rid of that too. And you'll notice that there aren't really trackers over here at all. It wasn't looking in that direction. And we do want to have trackers throughout the entire environment. And the next sections of the tutorial will be looking at 2 different ways to do that are similar but different. So I'm just going to give a little preview of what's going on and point something out too. So the camera's looking off to the side and down relative to the path, because those are the numbers that we had fed into it initially. And the camera really had been looking exactly backwards, as it turns out, initially. So what let's do, let's go back to our view here. And I'm going to run one script first. And now what it's done is switched back to that 360 VR shot. It's turned off the process of creating a narrow field of view linear shot. Now we're back to the whole wide shot. And you can see the trackers have all been updated to follow along. And it's maintained the orientation of the camera that was generated by the solve, so that the center part of this image is still exactly what the camera was looking at during this initial solve. It hasn't changed the camera path at all. And this is the setup to one of the next tutorial stages. And you see how irregular the horizon is here. That's something that's dealt with later, but let's take a look at that right now. I'm just undoing what I had done previously, and we'll go back and do stabilize from camera path. And now we're back in the full 360 VR mode, and you can see now that the horizon is flat. If you look up here in the camera path, you'll see the camera is now looking straight ahead the entire time. As a matter of fact, it's level with no twist. It's exactly level. The orientation is completely unchanged over the duration of the shot, and it's lined up with the horizon, as determined by that little flat section of ground down there. So as you scrub through the shot, you'll see how stable everything is. And that kind of absolute global stabilization is great for users to be able to maintain their understanding of where they are in the 3D environment. One of the things that you'll notice in this, if you just take a look at the sun as I scrub through this, you can see that it stays fixed in the same direction. It's very, very far away. If you think about that, you'll see that that's exactly what you expect to have happen if you're maintaining an exact orientation for the camera. So that's giving you two different looks of where we're headed next. And at this point, we'll segue on to our next section. Thanks for watching so far.